Well, hello everybody. Oh my gosh, how we doing? You doing okay? I'm just gonna factor a couple of these for you. All right, so let's get to it. Enough chatter, enough talking. Let's just get the factoring. Number one. Okay, so remember we've got a couple of methods to factoring. The first is we kind of assume what the answer is going to look like. Because remember, factoring is the creation of multiplication. When you factor 21, you say it's 7 times 3. So we're going to create this multiplication. So we basically know it's going to be x times x is going to get us the x squared. Where's some more markers? Oi, oi, oi. I am really low on markers. I tell you what. Okay. So we're set up because I know that's good. That's got me my x squared. So these two terms are going to have to get me negative 16. So I've got a couple options. I've got 4 times 4. But I don't think I'm not going to use 4 times 4 because I can kind of preview the answer. So I'm going to go 8 and 2 because 8 times 2 is 16. Now one of them has to be negative. And because ultimately they're going to have to add to this middle term, you want the bigger one to be negative because it must add to a negative. All right, so there we go. We got the 16. This should work. Let me check. So I'm going to go here and here. That's x times 2 is 2x. Negative 8x, and those would add to minus 6. So it works beautifully. So that's kind of the reverse foiling method, right? So you have a sense, there's a little bit of a guess and check kind of built into it. Sometimes, you could think about it as a puzzle, right? Because really what you're doing is you're finding two numbers that multiplied to get us to negative 16, but then those same two numbers needed to add to minus 6. So there we go. Turned out to be a negative 8 and positive 2. Let's move on to number 2. I would say the majority of the students right now in this class are doing the area method. So let's draw. It's not a square. I mean, because I know 24 is not a perfect square. So this is going to be a rectangle. We know that the first term is going to be created in that box, and the 24 is going to be created down there. And I'm kind of getting up and leaving right now, so don't worry, not going far. Okay, I'm back. I feel like I'm on radio or something. I'm like, I can't have no dead time, no dead air. You just gotta keep talking, even if I get up and leave. Okay, and then we have these two areas here. What I have now, I'm shading in blue, and they are going to have to add to 14. And so when you're doing these problems, you're like, okay, I know that's going to be x times x because that's how we get to x squared. And we ain't using fractions, so it's not going to be 2 times a half or 3 times a third. So it's just 1 times 1 is 1x squared. Beautiful. I mean, 1x times 1x is 1x squared. Okay, so 24, I know I could do 6 times 4, but I don't think I'm going to get to 18 on that addition. I could do 8 times 3, but again, well, I said 18, but I'm not going to get to 14 on that addition. That's probably going to get me 11, could get me maybe 5, depending if one of them's negative. But it looks like 12 and 2 is what's going to get me to 14. So let's do that. That makes this area 12x, this area 2x. If I add all these areas up, I get x squared plus 14x plus 24. Therefore, this equals x plus 2, x plus 12. Beautiful. Oh my. I am so happy. All right, let's move on and do number 5, just because it gives me I got some room. So let's do number 5. All right, we have our x squared term there. So I'm gonna do this one with the box method again, or calling it the box method, but should really call it the area method because mostly uh, uh, taking advantage of the geometry of the area of a rectangle. Okay, so I have x squared, it's gonna go there, and we know this minus 5, that's gonna be generated down here, that's this area. And now these two, which I don't know what they are individually right now, like there's no guarantee. I just know that they have to add to 4. So I know what they're adding to, oh, I mean 4x, but I don't know what they are individually. So there's a little bit of a guess and check into factoring, and the more you do it, the better your initial guesses will be, and so then obviously you'll start to go faster and faster. So we're lucky because 5 is prime, so it actually has to be 5 times 1. There's no way around it. One of the two numbers has to be negative, and because they're adding to a positive, I'm going to make the smaller one negative. So that means this area is 5x minus 1x. So we got our x squared minus 4x minus 5. So therefore, the dimensions of the rectangle that has this area is x minus 1 times x plus 5. Beautiful. So beautiful. And just to check, let's just check. Let's act like we are still unconvinced. Let's plug in the number 2 for x and see what happens. So I'm going to ignore problem 8 for now and act like it's not there. I'm the teacher. I could do that. Don't try that at home. Don't try that at home, but I'm the teacher. If I want to ignore the problem, I'm just going to ignore it. Okay, so we're still on number 5, and I'm plugging in the number 2 because I want to show you, I want to like kind of convince you that this is the correct answer. So we have 2 squared is 4, plus 4 times 2 is 8, minus 5. So 12 minus 5, or 7. Okay, so when x is 2, we have 7 as our solution. Now, let's go to our other answer, which is going to be x minus 1 times x plus 5. Let's plug in that same number 2 for x. See what I'm doing here? So this gives me minus 1 times 7. I'm sorry, 2 minus 1 is not minus 1. Yeah. Well, actually, I'm watching the Niner game pretty soon. So there's my Montana jersey. It is Sunday, so that's why you have to forgive my little errors. Okay, so it's 7. So kind of the purpose of what I just showed you here is that these are equivalent statements. Like if you plug in the number, they're equivalent expressions. If you plug in the number 2 up here, it's exactly the same as plugging in the number 2 down there. All right. Beautiful. Let's turn it over. Because the situation gets more challenging when you have a little number in front. It doesn't make it, in a sense, I don't even know if challenging is the right word, but it makes it take a little bit longer. So let me pick one of them, and I'll pick this one, number 5. So if I'm going to go this direction, I'm going to kind of reverse the foiling process. I know this first term has to be this value times this value. So I'm going to go 5n times n. I'm really lucky that 5 is a prime number. It really has to be 5 times 1. So I know that that's going to work. 72, however, one of those numbers that has a few ways of getting to 72. So let's see what we got here. So we got to think about how do you multiply to 72? Well, 9 times 8. And I think I'm going to go that direction. Yes, I'm going to go that direction with both of them negative. Because 5 times 9, just trying to think already, how do I get to 49? 5 times 8 is, oh, okay. So now there is a guess and check, but you can kind of see I'm making sure my first guess is correct. But let me check. So how do I know this works? Because I've got my 5n squared term. My -9 times -8 gives me my positive 72. So then because remember, FOILing is a double distribute. So I got to do this term times that term. That's 40n minus, because of the minus sign. And -9, that's -9n. And you can see they do add to 49. So it works. You know, if I had switched these around, it just would have not worked. It would not add to 49, and then I'd have to try different numbers. There's a certain iteration to all of this. Let's try number 7. And I'll try it using the area method. So I'm going to make the box. I'm going to put what I definitely know to be true. And now I've got options, because it could be 1 times 4, or it could be 2 times 2. And I honestly, as I'm talking to you right now, I don't know which one it is. And I'm just going to commit to one of them using pencil. And if I can't figure it out, I'm just going to pick a different one. All right, so 30, I'm thinking 6 times 5, or 3 times 10, or 15 times 2. So let me do 6 times 5 really quick and see if it works. That would give me 12y, 10y. That does not add to 29. So you can see it didn't work, because this adds to 22. So it's not 6 and 5. Let's do 10 and 3. See if that does anything for me. 2 times 10 is 20. 3 times 2 is 6. That gets me to 26. So that didn't work either. So let's do 15 and 2. But 15 and 2, I know it's not going to work, because that's going to give me 30, which is already too big. So I'm going to keep track of what I tried. So I tried 6 times 5. That didn't work. I tried 3 times 10, and I tried 2 times 15. I don't think there's any other way to multiply to get to 30. So I just don't think it's 2 times 2. I think the initial move is probably supposed to be 4 times 1. So I went from my first guess being right to now the first guess isn't right. And that's okay, because I'm not really in a hurry. So let's see here. Okay, I got to get to 30. I could try again 6 times 5, like I started before. I'm going to put the 6 by the 4, because as I think this is going to work. That's going to give me 24y, 5y, and there we go. That adds to 29, so it works. So the answer is 4y plus 5 times y plus 6. Beautiful. So beautiful. Now, what if that's just a little too much? Maybe you want a little bit more certainty in your life. Let me show you how to get a little bit more certainty. We're still on number 7. So let's go back, act like we don't know the answer. All right, so assuming we don't know the answer, here's how you can get a little bit more certainty. You do this puzzle, and you find 2 numbers that multiply to a times c. Well, I'm not doing number 8, but a times c. I'm going to scribble this one out, because I'm not doing it. It's confusing me. So 4 times 30 is 120. And the middle is 29. So you look for a puzzle, right? It's a puzzle. You got to find 2 numbers that multiply to give you this top one, but add to give you the bottom one. And it turns out that is 24 times 5. And that's how, if then I could go up here and I could know that that's got to be 24 and it has to be 5. And that, it's not a guarantee that, okay, now you're going to know how to do it, but it's, it's helpful because you're kind of unraveling this puzzle to have as many puzzle pieces there as you can possibly have. So there we go. I hope you enjoyed this quick tutorial, and I hope this video finds you well and in good spirits. All right, you take care, and I'll see you soon. Bye-bye now.